Good morning, everyone. Myself Lakshmi Priyanka Nanapaga, and this is my student ID. So, my research is titled An Imbalance Aware Machine Learning Framework for Customer Churn Prediction. Customer churn prediction means customers leaving a service provider, and this is a major business issue in sectors such as telecommunications from both academic and practical perspectives. Churn prediction is important because it helps organization identify at risk customers early and design together retention strategies. In this research, I treat churn prediction as a supervised binary classification problem, and I focus specifically on improving prediction under a class imbalance while also maintaining model inportability. Research aim and objectives. The main aim of this study is to develop and critically evaluate an imbalance aware machine learning framework for customer churn prediction, with the particular emphasis on detecting minority class churn cases while still keeping the model imperturbable. To achieve this, the study first reviews the literature, then prepares and pre-post process the dataset, applies SMART for imbalance handling, compares multiple machine learning models, evaluates them using several metrics, and finally using explainability methods such as shape to interrupt the best performing model. Problem statement. The core problem is that customer churn is both financially important and technically challenging. And most churn datasets, non-churn customers significantly outnumber churn customer. Because of this, a model can produce high overall accuracy while still performing poorly on the churn class, which is actually the most important one from a business perspective. Another issue is that stranger models are often less interpretable. So the real research challenge is not just building an accurate model, but building on that is imbalance aware, practically useful and explainable. Literature review and research gap. The literature shows a clear progression from traditional statistical models to more advanced ensemble learning approaches. Logistical regression remains useful as an interpretable baseline, but it often cannot model complex nonlinear interactions. More recent studies increasingly support random forest and boosting methods such as XGBoost and LightGBM, especially for structured tabular data. At the same time, many studies mention imbalance but still relate to much on accuracy, and interpretability is often treated as an odd on rather than a core design element. This credits the research gap may study addressing the combined class imbalance holding, comparative modeling, and explainable AI with one integrated framework, dataset, and data collection. The research uses the IBM Telecommunications Customer Churn Dataset, which is a well known benchmark dataset for churn modeling. It contains 7,043 customer records and 19 predictive features covering demographic characteristics, services, uses, and financial information. The target variables is binary representing whether a customer churn or not. I selected this dataset because it is structured, relevant to the telecom domain, and suitable for systematic machine learning comparison. And data pre-processing pipeline. The pre-processing state is critical because raw business data is not directly suitable for machine learning models. In this study, pre-processing includes cleaning the data set, correcting inconsistent data types, handling missing values, encoding categories variable, and standardizing numerical features. A stratified train test split is then applied to preserve the class distribution. An important technical point is data leakage prevention. So all performing transformations are fitted on the training data only and then applied to the test set. Handling class imbalance. One of the most important technical issue in this work is class imbalance. Since churn customer or the minority class, standard classifiers tend to favor the majority class, which leads to weak churn detection. To address this, I use the synthetic minority oversampling technique on the training data only. Instead of simplifying duplicating minority examples, SMART creates a synthetic minority samples which helps expand the decision region of the churn class and improves the model sensitivity to at-risk customers. Model development and a technical approach. The model strategy follows a structured progression from simple to more advanced method. Logistic regression is used first as baseline because it is inputable and provides a reference point. Random forest is then used to capture non-linear interactions through bagging. After that, I apply boosting based models significantly XGBoost and Light GBM because these methods reduce error and a particular strong for structured tabular dataset. This comparative design is technically important because it allows me to evaluate whether increasing model complexity produce meaningful performance improvements. And evaluation and testing strategy. The evaluation strategy is designed to reflect the nature of a problem because this is an imbalanced classification task. Accuracy alone is not reliable indicator, so I use multiple evaluation metrics, including precision, recall, F1 score, and ROC AUC. Recall is especially important because it measurable how many real churns are correctly identified. I also include confusion metrics, ROC curves, and the precision recall curves to provide a deeper understanding of the model behavior across different thresholds. Um, Key finding and interpretability. The findings indicates the ensemble methods outperform the baseline linear model with light GBM, giving the strongest overall balance of predictive performance. Logistic regression is still remains useful as a benchmark and offers strong interpretability. The analysis also showing the contract type and monthly charges and the most influential predictors of churn to make the model more actionable. SHAP is used to explain protection both globally and at individual level, which is valuable for business decision making. Um, Legal, social, ethical, and professional issue. This research also consider legal, social, ethical, and professional issues. Legally, churn protection connects to data protection and profiling, especially under GDPR in real-world application. Socially poorly designed models can lead to unequal treatments or reduce the trust in digital services. Ethically, the use of customer history must be transparent and fair. Explainability does not automatically generate fairness. Professionally, the study must remain methodologically rigorous and honest about this limitation. Um, Limitations, contributions, and conclusion. In conclusion, this study contributes an integrated framework for churn prediction that combines robust pre-processing, imbalance handling, comparative machine learning evaluation, and explainability. While the IBM dataset supports reproductivity and comparison, it may not capture the full complexity of operational business data. So, this is one limitation. Another is that Smart can introduce synthetic noise near class boundaries. Even so, the framework shows the boosting based models, especially light GBM, are highly effective for structured and prediction. But minority class detection and incompatibility must remain central rather than secondary concerns. Thank you. Thank you for this opportunity. Wait, let me stop.
We'll edit that part.